Dr. NGR Educational and Research Institute, University, Mother of All, Chennai. Dr. NGR Educational and Research Institute, University, Mother of All, Chennai.
I start with the words of Dr. APJ Abdul Kalam. All of us do not have equal talent, but all of us have an equal opportunity to develop our talents. Remember Sir C.V. Raman birthday, his wonderful words, success can come to you by courageous decision to the task lying in front of you. Welcome to all dignitaries, faculties, students and participants of various institutions for attending this national level hands-on training on virtual lab. Well, myself, Dr. S. Chellammon, Professor, Department of Physics, will be your host for the day. I am very happy to extend a warm welcome to our guest of honor and speakers for the day, Dr. A. Nazar Ali and Dr. K. Premkumar, Associate Professors in Department of Electrical and Electronics Engineering, Rajalakshmi Engineering College, Chennai, Tamil Nadu. This session will give an idea of experiments of electronics in science field. This session is aimed to create practical knowledge for the field of electronics and how their features can be developing in various fields. I request source of motivation and encouragement, Head of the Department of Physics, Dr. S. Radhakrishnan, request to deliver the welcome address.
Thank you, Madam. Good evening to all. Respected Dean Sir, staff members, speakers of the virtual lab, Professor Nazar Ali and Professor Premkumar, dear students and participants. First of all, let me thank our Honorable President for permitting us to conduct this training virtual lab, and also thanks to our JR, Dean and Deputy Dean for their support. I am happy to welcome our Dean, Dr. S. Manivannan, who needs no introduction, is tuning our HNS campus in an appreciable and technically developed level during this lockdown period. I welcome you, sir. I am pleased to welcome our speakers of the day, Dr. Nazar Ali and Dr. Premkumar, Associate Professors, EEE Department of Rajalakshmi Engineering College, for accepting our invitation. I welcome both, sir. Also, I extend my warm welcome to our staff members, participants, and my beloved students for this workshop. My special thanks to Dr. G.R. Subashri for arranging this training program. This is the second virtual lab in continuation of the first conducted by Professor Raju Padangani of Kidajali Engineering College, Kisara, Hyderabad from 8 to 10th June 2020. Virtual lab is a remote access to lab. Now is a boon in learning advanced concept through remote experimentation. It allows students to complete lab at the expense online and explore the concept and theories without stepping into physical science lab. I request all our students to utilize this wonderful opportunity. Thank you.
Thank you, sir, for your kind words. Motto of work: humanity, excellence, dignity of Dean, Dr. S. Manivannan, request to deliver felicitation address.
Good evening, one and all. It's my pleasure to present the felicitation address. And before to that felicitation address, I am really happy to share the ISO certification what we have obtained for the workplace safety. Let me read that one. That is called the ISO WASH certificate, called as Workplace Assessment for Safety and Hygiene, called as WASH, W-A-S-H, to help any organization assess its preparedness to restart and run operations safely against COVID-19 for any faculty members or the students. Really, I'm happy to inform all of you that Dr. MGR Educational and Research Institute, comprising all the campuses, Madurai campus, of course, Adayalampattu East as well as Adayalampattu West, of course, our Thiruvarkadu Medical Campus. All the three campuses have successfully appeared for this ISO, TUV, SUV, wash inspection successfully and made compliance to all the requirements. And really, I'm happy to inform that we have obtained this wash certificate, and that shows our dedication during these pandemic times in terms of receiving the students against the restarting. With this good note, let me thank my President, Engineer ACS Arun Kumar, and our beloved Vice Chancellor, Dr. S. Rajalakshmi, for according the approval for conducting this kind of innovative events. Thankful to them. And of course, it's my duty to welcome the chief guests of the day, Dr. Nazar Ali and Dr. Premkumar, Associate Professors joining from Rajalakshmi Engineering College. I'm once again happy to tell I'm also belonging to electrical department, such that I can welcome my colleagues of my own field. Obviously, this virtual laboratory is the quite interesting segment where we are missing that component. Obviously, we have covered the theory portions, but we are not having adequate knowledge how we can make up with these kind of laboratory components. Fortunately, the MHRD initiative fills this gap. Probably in any semester, we will be having 6 theory and 2 laboratories. These 2 laboratories are also important equally, since most of the courses are with the professional degrees. So handling these kind of laboratories are inevitable. So with the little bit knowledge on this virtual lab training will enable all the participants who are joining today, I can say webinar or hands-on training arranged by this Department of Physics, Adayalampattu campus of our Dr. MGR Educational Research Institute is going to be useful for all of us. I'm once again congratulating Dr. Rajalakshmi sir and his team, especially Dr. Chellamal, Dr. G.R. Subhasri, Dr. Kavita, of course, technical lead taken by Ms. Akshaya, who are doing wonderful job for this kind of nice arrangements. I wholeheartedly congratulate and let me pave way for the chief guests to share their valuable address. Thank you.
Thank you, sir, for your wonderful words. Dr. G.R. Subhasri, Associate Professor, Department of Physics, I request to deliver introduction about our resource persons.
Thank you, ma'am. Happy evening to one and all present over here. It's a pleasure to introduce Dr. Nazar Ali, who has completed his doctorate in power electronics and drives on the topic performance analysis of different dual Z source interfered induction motor drive, Anna University. He has completed his ME Power Electronics and Drives in Anna University, and he is a proud university second rank holder. He is currently Associate Professor in Rajalakshmi Engineering College 2018 till date. He has been Associate Professor and Head in K. Ramakrishna College of Technology, Annai Madhamal Sheila Engineering College, and he has also been working in M. Kumarasamy College of Engineering, St. Xavier's Catholic College of Engineering previously. He has 30 Scopus journal publications, 20 conference presented, 3 books published, 87 guest lecturers organized, and 25 FD-phase workshops and seminars organized. He is Young Scientist Awardee from International Journal Ruler, August 2018. He has got Best HOD Award in HRM consecutively for 3 years from 2015 to 17. He has guided more than 40 UG and PG students for projects. He is a life member of ISTE, ECS, IJ Ruler, ISRD, and IAENG. He is a member of IEEE and IRED. He is also coordinator for Anna University affiliation, AACTE, AASHE, and NIRF. He is a magazine coordinator in Career Connect, Careers 360, India Today, and GHRDC, and he is also certified trainer for ISO 9001-2015. So I'm here also happy to introduce our chief guest, Dr. Prem Kumar, who has done his PhD in electrical engineering in artificial intelligence-based speed controllers for brushless DC motor from Anna University. He has done his ME Power Electronics and Drives from SSN College of Engineering. He is a member of IEEE and IRED. is currently Associate Professor in Rajalakshmi, Veerasamy Chettiar College of ENT, IFET College of Engineering previously. He has been a production engineer in Power Metal Technology Malaysia during 2008. He has 21 Scopus Journal publications, 18 conference presented, and has organized 5 FDPs, workshops, and seminars. He is a reviewer for international journals, IEEE Transactions on Industrial Informatics, IJEPES, Applied Soft Computing, Neurocomputing, ISA Transactions, and few more elsewhere publications, and also Neural Computing and Applications of Springer Publications. His research interests are solar powered electric vehicle, soft computing based controller, max PowerPoint tracking in solar PV cells. He is currently doing research in hybrid multi-level inverter for application level in standalone system. He has been sanctioned a fund by AACT to set up modernization and removal of obsolescence. He has completed a near 4 consultancy work. We are very much happy to have Dr. Nazar Ali and Dr. K. Premkumar to conduct this virtual lab workshop. Thank you, sir.
Thank you, madam, for your wonderful introduction. Resource persons Dr. A. Nazar Ali and Dr. K. Premkumar are real excitation for any young academicians. We are honored by your presence on this occasion, sir. We hope everyone enjoy with satisfaction. Once again, I welcome our guest of honor and speakers for the day. Sir, we request you to take over the session and share your knowledge.
Thank you, madam. Respected dignitaries, professors, dean, head of the department, and faculty members, and my dear students. Good evening to all. On behalf of myself and my friend, Mr. Dr. K. Premkumar, we express sincere thanks to MGR University Management, Dean Sir, Principal, and entire Physics Department. Especially my special thanks to Dr. Shubhashri Madam, because she only invited me, because normally when faculty members are interacted with us, immediately we ask a question, so who is benefited? So she said, sir, if you are taking this virtual lab, so surely it is highly benefit for our students. Then immediately I talked with Prem Kumar and given our acceptance. Okay, so in this virtual lab program, we are going to explain some list of experiments related to electronics lab. The already Dean sir and that head of the department, Dr. Rajalakshmi sir, clearly explained the importance of virtual lab. Actually, virtual lab is a project developed by MHRD through information communication technology. This is one of the important tool which is really helpful for faculty as well as students. The objective of today's program is how to effectively utilize this virtual lab. That is the one thing, and it gives awareness about this virtual lab. Okay, so I request to Dr. Prem Kumar sir, see this one. I hope that whether it is visible, MHRD website. So how to go to this website means request the participants from the Google link, type virtual lab. Then click the first link. I request Prem sir, go to Google, then type it virtual lab. Then click the first link, virtual lab. So from that, you get the window like this. So actually this virtual lab is a project initiated by MHRD through ICT, Information Communication Technology. Then from the bottom, you can see that various departments are there. Electronics and Communication, Computer Science, almost all the departments are there. But today we are going to concentrate some electronics related experiments. For that, we are going to Electronics and Communication Engineering department. Sir, please click Electronics and Communication. So here, if you click that, you can get the list of experiments for that particular department. So digital signal processing lab, basic electronics labs, many labs are there. You can click that basic electronics lab. So if you click basic electronics lab, you can get the window like this. Welcome to Basic Electronics Virtual Lab. From that you can get introduction about this lab, what are the experiments available, then instructions, then what type of technology they are using, people, feedback, etc. So here you can click list of experiments. So from that you can see, so 17 experiments are available, especially for this basic electronics course. The first experiment is familiarization of resistor, familiarization of inductor, familiarization of capacitor, etc. So here 17 experiments are there, but due to time limit, I'm going to explain to only some 3 experiments. First one is forward bias characteristics of diodes, then half wave rectifier, BJT CE configuration. That means CE characteristics. Okay. I request Premkumar sir first to click VA characteristics of a diode. Okay. If you click that, you can get a window like this, VA characteristics of the diode. So in each experiment, theory, viva question, procedure, then how to give connection, everything is available. So I think it is a simple website, so we can effectively utilize. So I request Prem sir click simulation. So if you want to do the experiments, you go for simulation. Then from that, they mentioned that VA characteristics of diode, then forward bias characteristics, reverse bias characteristics, everything is available. So first one, you can click forward bias silicon diode characteristics. If you click that, you can you get window like this. First of all, I request the participant, you see the instruction. Based on the instruction, you can give the connection. So for example, here first they said set DC voltage to 0.2 volts. Premkumar sir set 0.2 volts. Yes. So if you vary that, then you can see the plus battery. So the battery, you can see that from the battery plus minus terminal, or one box will be there. From the box, you can see that value 0.2 volts. Okay. Then next thing is you have to set the resistor value. Before that, you select the diode. Sir, you select the diodes. If you click that, many numbers are available. You can click any one type of diodes. Then you can set the resistor value. Set the resistor value. After that, so you know how to do this experiments, forward bias characteristics. You can increase the DC voltages, then take down the voltmeter and the ammeter reading. So now you can vary the DC voltages. Sir, you can go up DC voltage. Then add to table. If you add to table, you can get the values. So from the tabular column, you can see that forward voltage and forward current. Then again you can vary the DC voltage. Again you can add it to table. Then you can get the second reading. Similarly, third one. So you can get the third one, fourth one, okay, fifth one. Okay, after that, if you want to know the characteristics, if you want to know the graph, you can click plot. Then go down, then you can see the characteristics. This is the VA characteristics of silicon diode. That is forward bias characteristics. Okay, actually here the physical connections, everything is available. Suppose if you want to give the connection, for example, separate DC source, separate resistance is separate, DC source is separate, then the instruments like ammeter and voltmeters are separated. Normally what we are doing in the lab, so first thing is write the apparatus requirement, then given to lab instructor, then get the apparatus. After that, give the connection. Then if you want to give the circuit connection, it is also available. Sir, please go to back, sir. Then from that, yes sir, forward bias silicon diode, draw a circuits. Yes. So here the components are separated. So if you don't know how to connect it, means you can see the instruction. So here some numbers are there. Okay, if you read the instruction, based on the instruction, you can give the connection. Prem sir, first to 1, 3 to connect it, sir. 1, 3. So positive supply is connected to resistor. Then next, yes sir, connected in series with the meter. Next, this terminal is connected to here. Then next 11 is connected to 2. Everything is available in the instruction. So if you follow the instruction, they clearly explain how to give the connection. Then after giving the connection, you can check whether it is correct or not. If you click the check connection, so it shows a wrong connection. So if it is a wrong connection, means so again you can click it. So 1, 2, 3, this one. Next another one. Yes sir, correct. Next. So after complete your connections, then you can give check connections. So from that you can get right connections. Then you know the procedure. Then you can click OK. Then first you set the DC voltage, some voltage range, 0.2, 0.3, point whatever it may be. You can set first to select the diode, then set the DC voltage, then set the resistance value. After that, you can vary the DC voltage and take down the forward voltage and forward current reading. Then again add a table. Again vary the input DC voltage. Again add a table. So you can take some 5 to 6 readings. If you want to see the graph, give plot. Okay. Then I hope that it is visible. So this curve shows the VA characteristics of silicon diode. Okay. So I hope that you can clearly understand how to do this experiment. First, we can see almost all the components are interconnected. So there, first we set the select the diode, then set the DC input voltage. Next, set the resistor value. After that, vary the power supply, vary the DC power supply, take down the different readings. That means forward voltage and forward current. You have to take 5 to 6 readings. Then after that, if you give the plot, you can see the curve. Okay, Prem sir, go to next. No sir, no need sir, no need sir. Go for next. Halfway rectifier. So again, if you click the list of experiments, so you so many experiments are there. Now I am going to explain a half-wave rectifier. Already you know what is rectifier. So it is a circuit which convert fixed alternating current into DC current, AC to DC power conversion. So 3 types of rectifiers are there: half-wave rectifier, full-wave rectifier, bridge rectifier. So now I am going to explain half-wave rectifier. So it convert a fixed AC into fixed DC. So you know how half-wave rectifier circuit consists of only one diode. Okay. So here you see that this is the circuit connections. So already I said each experiment theory is also available. Viva question also available. Procedure is also available. How to give the connection, everything is available. Then if you want to do the experiments, you click simulation. Then if you click the simulation, you get the window like this. From that, you have to see the instruction. Based on the instruction, you have to give the connection. Actually, here they said first set the resistor, load resistor value, some value. Okay. Then after that, what is the second one? On button. So you go down. So from that, on button will be there. Down. So on this button, this is on button. So give the power supply. Then next, click the sine wave. Step number 3, click the sine wave. That means you have to give the input. Then next, click the oscilloscope. Click the oscilloscope. Then if you click the oscilloscope, you can get the output waveform. Half-wave rectifier means 50% of that means positive half cycle only diode conduct, so you can get only positive half cycle. So next, if you want to vary the magnitude, sir, if you click dual, you can get 2 waveform. So please click dual. Yes. Then I think here you can show some 2 waveforms. If you want to show some differentiate for that, yes, sir. Go up, sir. Go up, sir. AC is converted into DC. Go up, sir. Yes, yes, yes. This is our AC waveform. So blue color waveform represent input waveform. Then the red color waveform represent output waveform. So it convert fixed AC to fixed DC. Then if you want to vary the magnitude or time period, so from the bottom it is available. So if you change it, there you can see the waveform changes also. Okay. So if you want to calculate the ripple factor and other values, so the bottom formula will be there. So it's automatically calculated. Okay. So this one shows the half wave rectifier circuit. First step is set the load resistor value. Then second step is click on button. Then third one, click sine wave. Fourth one, click oscilloscope. Then if you want to know a 2 waveform, click dual channel. You can get both waveform. Then if you want to vary the magnitude and frequency, then that is also available here. You can vary and take down the different readings and different waveforms. Okay. Prem sir, go back, sir. If you want to draw a circuit, that is also available here. So half wave rectifier circuit. So previous one, almost commons are interconnected. That means a diode, function generator, everything is interconnected. But here it is separated. So based on the instruction, you have to connect it. So I request to Prem sir give connection. Sir also given connection based on the instruction. From the instruction, they clearly mention where it is connected. At present situation, it is too difficult to do physical experiments at your lab. So for that, government taken this project. It is the excellent tool for teachers as well as students. So after giving the connection, you can check whether it is correct or not. So right connection. So if it is wrong means, so once again you reset. A right connection means okay. Then you can do as per your procedure. So what we discussed, the first step is vary the set the resistor value. Then second thing is click on button. On button. Sir, it is available here itself. Check button. Yes. Next one. Then if you want to vary the amplitude, magnitude, frequency, you can vary that. Take down the readings and draw a graph. Okay, so far discussed some two experiments: forward bias characteristics, diode forward bias characteristics, then half-wave rectifier. Now I am going to explain the CE characteristics. So here also that theory, procedure, everything is available. So you are going to do the experiments by clicking simulation. So if you click the simulation, you can get two characteristics. One is input characteristics and another one is output characteristics. Prem sir? Hello? Prem sir?
Yes, yes. Tell me, sir.
You can click simulation button, sir.
Yeah, I already clicked that one. Okay. You will see
I am
that.
not showing that. I am not showing that window.
No, no. You can see that window. PJT-C input characteristics.
Okay, sir, but it is not visible to my mobile. Okay, sir. If you want, you can proceed, sir. Sir.
Okay, okay. I will continue from here, right?
Okay, sir. Okay.
Okay, okay. Thank you, Nasser.
Sir, 1 minute, sir. 1 minute, sir. So
Yes.
actually, so BJT common emitter characteristics. Here two types of characteristics are there. One is input characteristic and another one is output characteristics. So input characteristics means here we are going to set VC is constant, and we are going to vary VB. Draw a graph between VB versus IB. That will be explained by my friend Mr. Dr. Premkumar. Sir, you
Okay.
will continue, sir.
Thank you. Thank you, Nasser. So my voice is audible to you? Okay. So in order to do this experiment, just you have to go to instruction first. Okay. So first you have to read that instruction fully, and then you have to do that experiment. So first you have to set the rheostat RH1 equal to 1 ohms and rheostat RH2 equal to 1 ohms, and then set collector emitter voltage equal to 1 volt by adjusting the rheostat RH2, and then we need to vary the base emitter voltage by varying that RH1. So for different value of that base emitter voltage, you have to note down the reading. So this is instruction given for that BJT common emitter input characteristics. So first we need to set rheostat RH1 and RH2. Here you have to adjust. So first you have to set 1 ohms. Okay. So after that we need to set voltage across collector and emitter equal to 1 volt. That means this point, right? Collector and emitter. So you have to set voltage across this equal to 1. So further you need to adjust this rheostat. Okay, it is connected with this power supply. So for that just you have to adjust this RH2. So I'm going to adjust this RH2, and then I'm going to make that voltage across that common collector and emitter equal to 1 volt. Okay, here. Okay. So after that, next you have to adjust the base current by varying that rheostat RH1. So for a different value of that base current, you have to note down the reading. Okay. So first I'm going to note down the first reading. So for that I'm going to click this link, this button, output table. So after clicking that one, you will see that a reading will be available in the table, right? So collector emitter voltage equal to 1 volt, and base emitter voltage equal to 0.02, and then base current equal to 2.058 microamps. Okay. Next you need to adjust that RH1. So next time you would adjust this one, and then you need to store that data. So for different reading, just you have to add that value into the table. Okay. So by changing the R version, you will see that meter, right? Meter varying, a voltmeter, ammeter of that base emitter as well as collector emitter side. Okay. Just you will adjust this RH1 and then just add the data into the table. Okay. So after adding this data, you want to plot the graph between two things. One is base emitter voltage and then base current. Okay, so for that, just you go to click this one. If you click this one, it will be going to draw the graph between base emitter voltage and the base current. So simplest experiment in that we lab for BGT, common emitter input characteristics. So first you have to go to instruction and see read that instruction. So based upon that instruction, just you have to do that experiment. So finally you will get that graph between that base current and the base emitter voltage. So next I'm going to do that BJT output characteristics. Okay. So for that, just you have to click this link. So it will be navigate to this window. So here also we need to first read that instruction. Okay. So here BJT common emitter output characteristics. Here we need to fix that base current constant, and then we need to vary that collector emitter voltage by means of this rheostat. Okay. So first you got to read that instruction. So initially you have to set the rheostat RH1 equal to 1 ohms and RH2 equal to 1 ohms, and then you need to set the base current equal to 15 microamps by means of that RH1 rheostat, and then we need to vary that common emitter voltage by means of that RH2, and then we need to store that reading by using R to table concept. Okay, so I'm going to change that RH1. You can see that. So if you adjust this one, you can vary that RH1. So initially I'm going to fix RH1 equal to 1 and RH2 equal to 1. So this is output characteristics. So you have to maintain, that means you have to maintain that base current equal to some constant value. So here you are going to maintain, you are going to maintain that base current at 15 microamps. Okay, so you have to maintain that base current at 15.35 microamps. So next you have to vary that collector emitter voltage by means of RH2. Okay, so first you have to note that the first reading auto table. So this is initial reading. So the base current is maintained at 15.35 microamps. Collector emitter voltage is 0.1 volt, and the collector current is 3.2 milliamps. Okay, next time we will adjust that RH2, and then you can see that if I am going to adjust this one, you can see that variation that voltmeter. Okay, collector emitter voltmeter and the ammeter of that collector. Okay, so I'm going to add this data to the table. So next time I'm going to adjust the value and then add to table. So we can take different readings. You can take up to last, no problem. Okay. So after taking that reading, right, finally you need to draw the characteristics of that common emitter configuration at the output. Okay, that means so you need to draw the characteristics between common collector emitter voltage and the collector current. Okay, so for that just you have to click this plot. So this is the characteristics of that BJT under C configuration at output. So this is collector current, this is collector emitter voltage. So this is a variation of that graph for different readings. So student can easy to use this opportunity to do that experiment virtually. So that's all about that BJT output characteristics under C configuration. So next I'm going to explain about some digital electronics lab. Okay, that means how to do that logic gate operation, and then off order, full order, subtractor, off and full subtractor. Okay, so for that just you go to this one, digital electronics lab. Okay, so this lab is developed by IIT Roorkee. So we can see that the participating institute of that virtual lab. So for that, go to that top of that website. So we'll click this one. So you'll see that so what are the institute as participating that doing that developing that virtual lab. Okay, these are the institute or participating for developing that lab. Okay, so go to electronics communication and to do the digital electronics lab. So after clicking that one, just you go to click this digital electronics lab. So developed by the IIT Roorkee. Just you go to click. So after clicking that one, it navigate to another window. So you will see that introduction about that digital electronics lab and the objective of that digital electronics lab and the list of experiments. So experiment available under the digital electronics lab. Okay. So these are the experiment available under digital electronics lab. That means verification of logic gates and then construction of off and full order using XOR and NAND gates to study and verify the off and full apparatus. So many experiments available under digital electronics lab. So we will see one by one. So first we have to see about verification of uh, logic gates. So further, just you have to click this one. Okay. So after clicking this one, you will see that corresponding window for that verification of the logic gates. So we have different details: aim, theory, pre-test, procedure, simulation, post-test, reference, feedback. Okay. So you can click one by one. So you will see the details about that each option or each details about that verification of logic gates. So this is theory about that verification of logic gates, and then they are provided some MCQ questions relevant to that logic gates also. And then you can click this one user. So they are provided some instruction how to do that experiment by using virtual lab. So first you have to read that steps for that connecting circuit in order to do that experiment. Okay, just you have to read these things. So after reading that details, just go to simulation. After clicking that one, you will see that different option for doing that simulation. So here I'm going to do some simulation about AND gate. Okay, so it has two kind of simulator, right? Simulator 1 and simulator 2. So first you have to see about simulator 1. Okay, so this is the logic diagram for implementing that AND gate. Okay, it has battery, switch 1, 2 and 3. So switch 1 is used for connecting the supply to that this transistor logic circuit. Okay, and 2 and 3 used for giving a logic input to that transistor. So this bulb will be used for indicating the output of that logic gates. Okay, so first you need to connect that battery to that circuit. So for that you have to click that battery double time. So it directly connected with the circuit. Okay, when you go to click that battery double time, it's going to be connected. So next you need to energize this circuit, right? So in order to energize the circuit, you need to switch on that power supply. So by using this switch 1, so just go to click this switch. So after clicking the switch 1, so you will see that the change of color from red to green. That means the battery is connected with the circuit. Okay, so next you have to check the condition, logic gate condition. So already you know the truth table for AND gate. That means 0 0 means output will be 0, 0 1 output 0, 1 0 output 0, 1 1 the output will be 1. Here you can see the color of the bulb, right? If it is in the white color, it is known as in off state. Okay, if it is in on state, it's going to be changed to yellow color, right? So you have to check the status. So initially you can see that the switch position in a 0 position. Okay, so next I'm going to change the condition. Here I'm going to change the condition. The condition will be 1 0. The output will be 0. Okay, next I'm going to change the condition 0 1. So here also output will 0. So next time I'm going to change the condition, both are equal to 1. So you can see that variation. Bulb will be blue, right? So that's why you can verify the logic gate by using this virtual lab concept. Okay. So you can see that the different section about this details also. Okay. What I said, they will be available here. Okay. And also you can do that experiment by using simulator 2 also. Okay. So in simulator 2, they are provided some that mean and gate. So we need to key in that detail about that the input for that AND gate and output for that AND gate, and then you can check the condition by using clicking this one. So initially I'm going to type input will be 0, A and B equal to 0. Visually we know about the truth table of AND gate. If it is 0 0, output always equal to 0, right? In AND gate. So but I'm going to change output will be 1. Okay, that means we already know that this logic is not correct, right? So I'm going to check the logic. So I'm going to click this one. So after clicking this one, you will show that is the logic is incorrect. That means if it is input 0 0, output always equal to 0. Okay, so that is a correct logic about the AND gate. So here we are keying in this 0 0, output will be 1. The output is incorrect, so that's why it's showing incorrect. Okay, so here I am going to change output will be 0, and then I'm going to check the condition. So now you can see that the logic is correct for that AND gate. Okay, so that's why you can key in the input and output. You can check the uh, logic of AND gate by means of that simulator 2 also. Okay. Same way we can go for some other logic. For example, I'm going to NAND gate, execute NAND gate. Okay. So this is a circuit that means simulator 1 for that executing NAND gate. Okay. As usual, just go to click the battery. You have to supply the power to the circuit. Okay, just give it a double click. So it will going to be connected with the circuit. So next you need to supply the power to that logic circuit. Just you go to click switch 1. Okay, you can see that after clicking that one, initially the bulb will be blue. Okay, why? So as per the logic, NAND gate logic is working, right? Input will be 0 0, output will be 1. Okay, I'm going to change the logic here. For 1 0 also output will be 1. For 0 1 output is 1. For 1 1 output will be 0. Okay, this is a logic operation of the NAND gate. So logic is correct. Okay, so by using simulator 1, we can easily check that logic output of that NAND gate by using this circuit. So and also you can execute the same experiment by using simulator 2 also. So first one same process 0 0, output you can check 1, key in 1, and then check the output. Okay, just go to click, so you will see that. So output will be correct. If I'm going to provide 0, it will show incorrect. Okay, so by the way we can check the different logic gates by using this virtual platform, that means this platform. Okay, so next move on to I'm going to execute that means to study and verify the half and full subtractor. Okay, so I'm going to click this one. Here also you can see different option about that half and full adder. So about the aim of that experiment, theory about that half and full subtractor, and then pre-test quiz, and then procedure for that executing that experiment, and then simulation, and then after completing that experiment, you can go for some MCQ type quiz, and then reference about that experiments. Okay, so straight away I'm going to simulation, and then first I'm going to execute half subtractor. Okay, so for that just go to click half subtractor, so you will see that circuit for that half subtractor. So here also you have to do some basic things, so that means based upon instruction. Okay, so instructions connect the 5 volt supply to the AC. Okay, and then press the switch input A and B. So if this is the switch is in position, already this is on condition. If it is in position, this position is in off condition. Okay, so just you have to click this switch in order to give the supply to the ICs. So these are the input A and input B. here we are doing of subtracted, right? Just you got to subtract two things, and then what of the difference of the two inputs and the borrow of the two inputs, right? So initially you can see that the condition at 0 0. Okay, 0 0 means difference is 0, borrow also 0. So the both LED going to be in a active low condition, so it's not a low condition. Okay, so you can add this detail in the table also. Just click this one, you can add that condition to the table. Okay, next I'm going to change the input a, change to 1, here 1, here 0. So you can see the difference is 1 and borrow is 0. Okay, so you can add this output to table. Okay, you can add this details to table, and then I'm going to change that input b. So I'm going to make the input a equal to 0, input b equal to 1. Here you can see that the difference is already 1. Here the 0 minus 1, so as per that the borrow will be 1. Okay, so both LED is in on condition. Okay, so next you can add this detail to the table also. Okay, so next I'm going to make both input a and b equal to 1. So both will be equal to 1. So difference is 0, borrow is also 0. So you can see that the blinking of LEDs in off condition. Okay, so you can add this detail to the table also. So by the way, you can do that experiment for that of subtractor. So this is a simulator 1 window. I can go to simulator 2 as usual. So you can see the circuit also. So first just you have to click the circuit, so you will see the circuit for that of subtractor. Here also you can key in the input and output, and then you can check the condition. Here I am going to key in input a equal to 0, input b equal to 0. So I'm going to make difference equal to 0 and borrow equal to 0. Next I'm going to check the condition. Okay, so just have to click this one, you will see the condition. So condition is correct. So your key in input and output is correct. Okay, if suppose I'm going to change this one for the same condition, same input condition, I'm going to change the difference equal to 1 and then check the condition is incorrect. Okay, because the output difference is not correct. Okay, so it should be equal to 0. So here I'm keying into 1, right? So that's why it's so incorrect. Okay, so by the way you can do that half subtract. Okay, next we have to do some other experiment. Here I am going to do some shift registers. Here you have to do 4-bit serial in parallel out of shift registers. Okay, so you can see that aim theory about that serial into parallel out of shift registers. Okay, I'm straight away go to simulation. You can see that. So this is a simulating window for that 4-bit serial in parallel out shift register. Okay, so first you got to read that instruction. So connect the battery to supply 5 volt to the circuit. Keep the reset and preset as active high signal. Button in active high state are green, and the button in active low state are red. Okay, so apply the data at serial input by using this switch. So apply one clock pulse at clock 1 and observe the data at the LED Q3. Okay, and click add button to add data in the truth table. So you have to do same. Okay, for applying extra serial data input, and then you can click clock input and then check the output, or you can add that output. Okay, so first I need to connect this battery. Okay, so initially I am going to fix serial input equal to 0. Okay, I am going to give clock input. So just I am going to click this one. So you didn't see any variation at the output. Okay, So next I'm going to change the serial input to 1. Okay, 0 to 1. Next I'm going to click the clock. So you will see that Q3 it changed to 0 to 1. Okay, next you can add this one. Once again I'm going to give another clock. So you can see that Q2 is changed to 1. That means the data is shifting by one, right? Next I'm going to give the clock. So you can see that next data is shifted to Q1. Next time you click clock. Okay, you can see that the data is transferred to another bit. That means you are going to give the input serially, so it's going to be changed to parallel. Okay, so I'm going to change the input now. So I'm going to change serial input to 0. I'm going to give the clock input. So now we can see that. So input is propagated to in parallel way. Okay, so next I'm going to change to 1 and change to clock. So we'll see the variation in the outputs. Okay, so this is the experiment on serial in parallel output shift register. So before you doing that experiment, just you have to go to the different details, aim, theory, pre-test, procedure, simulation, and then do the experiment. So next move on to some other experiment. And then I'm going to do some experiment on a counter, right? Synchronous and asynchronous counter using JK flip-flops. So for that, just you have to click this one. And also here also you can see the different details about that experiments. So about that asynchronous counter and synchronous counter details. Okay, and then about that pre-test, that means MCQ type before that experiment you can do that, and then procedure for the doing that experiments and simulation. So after clicking that one, you can see that simulation about asynchronous counter and asynchronous counter. So I'm going to do that synchronous counter operation. So for that, just you to click that one. So we will navigate to this window. Okay. So this is a circuit for that synchronous counter with the JK flip-flop. So before starting that experiment, just go to see the instruction fully. So read the instruction clearly. First you have to provide supply, 5 volt supply, and then press counter button to start the counter, and then different combination of LED will light up for the different combination of the inputs. Okay, repeat the step 2 to 3 for another set of gate. So and then you can generate the waveform from that counter also. Okay, so this is the instruction for doing that experiment. So first I am going to turn on that 5 volt supply for the IC. So and then I'm going to trigger the clock. So here I'm going to trigger the clock. So after triggering the clock, you can see that the variation of that detail, that mean clock, and then we only set Q3, Q2, Q1, Q0 LED. Okay, next I'm going to increase. That mean trigger the clock. So you can see that variation at the Q0. That means LED is going to be glow. So you can see that variation. That means data change from 0, 1, 2, 3, 4, 5. Okay, for every trigger. Okay, so this is a 4-bit, right? So you can trigger up to 16. Okay, so you can see that the final output of that LEDs is all LEDs will be on because of that last trigger. Okay, you can see that waveform also for that output for every clock pulse. So you can see that. So for every clock input, so variation at the Q0, Q1, Q2, Q3. So this is a variation at the Q0, Q2, Q3. So that's all about counter operation. So Any doubt, you can ask question. Okay. Nazar Ali sir.
Thank you very much, Professor. Thank you very much.
Okay, okay. Any question from audience? So we can.
Thank you so much, sir, for delivering a wonderful and informative session. It's time for question and answer session. Dr. E. Kavita, Professor, Department of Physics, will be asking 3 questions.
Ma'am, your voice is not audible, ma'am.
Thank you, Premkumar sir, and thank you, Nazar Ali sir, for your wonderful
Thank you, madam.
presentation. Thank you. And hands-on training on the virtual lab. Really, it's a very fabulous session we have, and all our students get benefited. Thank you once again, both of you, and we have received very excellent feedback from our participants. Thank you, sir. And the first question, shall I ask the question, sir?
Yes, yes, you can ask. No problem.
First question is it possible to change the diode range? In our market, we are using diodes.
The diode already they are having some default numbers. Okay, so you can choose that one and then you can use that diode. So you cannot include any manipulation in that diode. So you cannot include
Actually,
already.
from the list they given some types of diode, madam. That diodes can be only used.
Yes.
Thank you, sir.
That means this model, that virtual lab is developed by NIT Surathkal. They are did for some specific details only. So you cannot do anything, right? So you can go there and then you can use that virtual lab for your lab purpose only. So you cannot do any modification.
Thank you, sir. How Zener diode can be used in voltage protection?
That means you need to connect that Zener diode and reverse bias. Okay. For example, you go to product system for a 9-volt system, right? Then you can connect that Zener diode and reverse bias. You can maintain that voltage at the Zener diode at 9 volt. Okay, in reverse bias condition.
Thank you, sir. The next question: how it can be used in clipping circuit? Give some examples in day-to-day life.
Clipping circuit means nowadays you can see that multi-level inverter, right? In multi-level inverter, you need to generate some triangular wave above that 0 level. Okay, so for that application, we can use a clipper clamper circuit. You have to generate a pulse width modulation signal, right? So in order to generate pulse width modulation, we need to use a different triangular wave and the sine wave. The triangular wave normally shifted with some offset wave. Okay, so in order to use that offset condition, we can use that clipper and clamper circuit.
Thank you, sir.
Especially this type of waveforms can be used for testing purpose, madam.
Oh. Next question, sir. Any free software available to develop stimulation for general physics and electronic experiment?
General physics, you can go for MATLAB. It's not free. You can purchase the MATLAB and then you can use it for physics. I think so. You can Scilab also. You can use that software. Scilab is open source software, so you can use that Scilab for your physics lab experiments.
Thank you, sir.
Madam, if they are having electronics means you can go for SPICE. Otherwise, MATLAB is available.
Okay. Thank you, both of you, sir. We had a wonderful session today with both of us. Thank you once again, sir.
Thank you, thank you.
Thank you, sir. Thank you, madam. Our live streaming is being overwhelmed with audiences. Thank you once again for accepting our invitation. I now call upon Dr. S. Radhakrishnan, Head of the Department of Physics, to deliver vote of thanks.
Dear friends, it is a pleasure in giving vote of thanks. Since I started with welcome address. It is really a pleasure in giving vote of thanks. I thank our Honorable President for giving permission for this kind of function. Secondly, I thank our Joint Registrar, Dean and Deputy who always giving full support whatever events we are conducting. Therefore, I must thank them. Thirdly, the success of the work is because of the coordination of our staff members who have been assigned various work. Dr. Chellamal for comparing, introduction of speaker by Dr. Shubhashri, Dr. Kavita Madam moderator, and vote of thanks myself, and stream out by Akshaya of English department, and also Google form formation, registration link, certificate designed by Mr. Ganesh Babu, System Administrator, Computer Department. I thank my colleagues as well as the participants and my beloved students for attending this webinar and make it a grand success. Thank you. Thank you.
Thank you, sir. In this happy moment, we would like to present our appreciation certificates to the resource persons. Display the appreciation certificates. The field YouTube description box. You are requested to complete and submit the form before today 7 p.m. Later, the form will be deactivated. The e-certificate for participation will be sent to registered email. The feedback assessment form is available to the YouTube description box. You are requested to complete and submit the form before today 7 p.m. Later, the form will be deactivated. The e-certificate for participation will be sent to registered email. This video will be ever available in our YouTube channel. Participants can view at any moment. We have come to an end of the program. Hope everyone has gained knowledge. With the satisfaction, we wish to sign off and meet you in the next program. Don't forget to submit your feedback form and subscribe our YouTube channel, Dr. MGR University Phase 2 Digital Learning, for further updates about our programs and videos. Stay home, stay safe, stay healthy. Thank you.